Hello, everyone, and welcome to this seminar. Apologies, I had the wrong name up there. This is AI, where we're going to be talking about how AI is impacting agriculture, and it seems to be happening very quickly. So if you have any questions throughout, I encourage you to ask them about any topic related to AI. It doesn't necessarily have to be something that we're talking about right now. And if you do have any questions, just raise your hand and we'll answer them in real time. So my name is Andy Castillo. I cover technology and machinery at Farm Progress. And on our panel today, we have Dan Curtis of Bayer, Benjamin Beer of AGCO, and Katie Stanton, who's representing Taranis. And so as we begin, I'll have each of them come up, introduce themselves, and then we have a brief slideshow just talking about what they do and what their brands are doing. And then after that, we'll get into a roundtable conversation. Dan, you're up first.
All right, my goodness, I didn't know we were going to put my face up on the screen there. More of a face for radio. And I'm sorry, I'm usually a dead ringer for Ray Romano, but today I'm more RFK, getting over a cold, so I apologize for that. But I'll talk about Eli. So at Bayer, we, about in 2022, saw these large language models and AI coming on the scene and getting better in different domains, and they were getting strong in agronomy. So my grandpa was a tool and die maker, and he had this thing when he retired where he would go to auctions and buy tools, and every time I saw him, he would show me a tool and he'd say, "Do you know what this does?" Well, he never went to college, and I never knew what these tools did, and he used to make so much fun of me. He's like, "You went to college, you don't know what this tool does?" And but that was kind of his hobby, and what it impressed upon me is there's a tool for everything, right? And you don't start with the tool, you start with the problem. And so this is the problem we wanted to solve with large language models, is that answers take too long in agriculture. When you're farming, sometimes you need an answer quick because timing is sensitive. And sometimes it's hard to get to an expert. And the way it works, sometimes you call one expert, they have to call other experts, and they have to wait for those other experts to come back to them before you get an answer. And so that's the problem we wanted to solve with these. And we think that there's a great opportunity to do that. So our kind of mission is that every farmer, regardless of location or resources, should have access to agronomic expertise they need for their success. And too often, even in the US, but also all around the world, getting access to agriculture expertise is tough. People turn over, they retire, they leave, and you have to rebuild trust, and you have to find a new expert. And so we think we can make more stability and make expertise more accessible. And so where are we with that? So today, we have launched a custom tool called Eli Chat in our organization. 1,500 frontline employees in our commercial business and in the agronomy organization are using it. And it's surprisingly accurate. So we've added 42% knowledge on agronomy over ChatGPT. So that's one of the most popular large language Gen AI solutions. And so we're adding a lot of information about specific contextual agronomy around our products and situations. It's more consistent, and we're finding our people are finding a lot of value. It's saving them time every week in terms of the tasks they have to perform. So now we're on this course to make it more mobile, make it smarter, and help train people on how to use these tools and pave the way to a future where we can expand access to other enterprises and to other players, including farmers in the future. So this one's got a little messed up on the thing. It's kind of hard to see, but just talk about where do I see AI headed in ag? I think we're reaching the end or maturity of precision agriculture, which has largely been hardware driven. And we're moving into this space of agentic agriculture. And we'll talk today about what an agent is. But the short of it is these tools are getting smart enough that they're smarter than most of the experts out there. In the domain of agronomy, they have kind of surpassed the average intelligence of most of the experts. And there doesn't seem to be a stop to that. And now increasingly you can point them towards actually executing tasks on their own, which I think is exciting when we think about integrating that with real-time sensors and systems so that they have the context to make good decisions and drive those good decisions. And then when we get to robotic agriculture, where you can use robots to perform tasks, I think these can be great partners to farming and getting more things done in agriculture. So I look forward to the discussion, and I'll turn it over.
Thank you, Dan. Ben, you're up next.
Good afternoon, everyone. My name is Benjamin Beer. That surname there is real. One of my ancestors apparently was Irish, and for them, that was funny. I am a project engineer. I work at a little company called AGCO Corporation, which is an American-based agricultural machinery company headquartered in Duluth in Georgia. There is our logo, the red background there. I'll jump over to this slide. This is just a bit of an overview of some of the key values as it references to our company. We're a pretty big company. We've got 24,000 global employees. We operate a very broad and very deep portfolio of products. So we have fantastic representation of whole goods machinery in our brands such as Fendt and Massey Ferguson and Valtra. But we've also realized that a lot of farmers have access to very good equipment on their farms today, and they want to add onto that equipment. So we've built a big portfolio of retrofit technology in our PTX brand with PTX Precision Planting and PTX Trimble. A little bit of an AI at AGCO at a glance. Obviously, it's a very big company all over the world. We've got 7,000 different ways we're using AI, so I'll highlight just a couple here on the slide. First up is something called Outrun, which is our autonomous grain cart solution. If you've been to the PTX booth here at the show, you would have seen it in the corner. This is a project that started with one of the most hard aspects technically of the combine, the harvesting season, which is the grain cart. From an engineering perspective, this is an extremely difficult problem to solve, but anyone who's ever been in harvesting or has done harvesting knows it's one of the key roles is to keep that combine just going. The combine can't go down at all. So to bring autonomy into this is a fantastic opportunity because now we can have a grain cart operator that's freed up that can maybe work on a semi-truck or that could potentially even be inside of the combine. Then I'll jump over there on the far right to Symphony Vision. Symphony Vision is a product from our precision planting division out of PTX. This is our reaction to some of the sustainability we've seen coming into agriculture today. We're trying to find ways to give farmers better equipment and be more judicious in how we're using things like chemicals and get lower costs on our inputs. And one way we can do this is using AI is we can give machines the sense of sight. So instead of just going out there and spraying everything with a chemical, we can use cameras and AI and we can actually give it the ability to pinpoint and look at specific weeds right down to, I think we're about half a penny's size. So any weed that's about the size of half a penny, we can spot with that system. I'll jump to one that's not explicitly mentioned here on the slide, but is an interesting internal product. It's one called Farmer AI. Whenever you ever see anything about AGCO, the two words farmer first are always everywhere. All of our marketing, all of our slogans. And to really take that to heart, what we've done in our company is we've taken a huge amount of agronomic data, a huge amount of open information about agriculture, and we created an internal AI farmer to allow our employees to understand the farmer better. If we're truly going to be farmer first and we're truly going to serve the needs of the farmer above all else, the best way to do that is to teach our employees what exactly is a farmer. What do they face? What are their needs? What are their problems? And how do they differ? How does a farmer in Kentucky differ from one in Kansas, from one in Washington perhaps? So we've used AI to do that internally, and it's been wildly successful. The last thing, and I left it deliberately for last, is this one here in the middle. It's called Talking Tractor. AI today, as we get into this discussion here today, we'll get into some of the details, but what AI really helps us to do is to bring the barrier of entry into technology a lot lower and a lot down. We've all played a little bit with Siri, or you've heard about voice assistants on your phone, but one of the things that stands out from that is just how natural it is to deal with that. You talk to your phone and your phone can talk back and potentially have a conversation. So last year at AGCO, we had this theory, and we said, well, why can't we do the same with a tractor? And at the end of last year, we presented a prototype of a technology called Talking Tractor, where we put this technology inside the cab of a machine. So instead of needing to go down in the field and call the dealer, hey, I've got this weird random error code, you just talk to your tractor. Your tractor will reply back and say, this error code relates to this, here's how you can fix that. Or this is what your fuel situation looks like. Or this is the status of what's going on with your implement at the back. So this is an exciting area of technology, and we're very specifically excited about this. When we presented this to a bunch of farmers as part of our Farmer First commitment, within the first 15 seconds of me talking with this, I had a farmer interrupt me from the crowd and shout, yes, if you have that, I'll take it. So I took that as good news, so I'm very excited to see where this goes. I'm happy to be here and happy to talk about this. I'll pass on to the next one.
Next up, we have Katie.
Hey, please tell me the voice of your talking tractor's kid from Knight Rider.
I make no promises.
I'm just going to angle a little bit because I'm much shorter. So my name is Katie Stanton. I'm representing Taranis today. I'm the Director of Customer Success. So I deal less on the actual building of the AI and the generation of the tool, but more of what can the tool bring to you. So as far as Taranis goes, as a show of hands, who has even heard of us or is familiar with what we bring to the marketplace? I love it. I love it. A room full of fresh people where we can bring a whole new perspective from agriculture. So with Taranis, we are technology that makes a difference with the retailer and the grower. We're bridging the gap for the service that you guys deserve as a grower, to know what's happening on every acre and where to really put your dollars exactly where they need to go. So we've flown with high-resolution drones, and if you take anything from anything I talk about today, remember leaf-level imagery. We are flying drones across your field, taking leaf-level imagery where we can spot tar spot in your field or identify insects by species, weeds by species, take stand count across every single acre to where you don't have to walk across those acres, and you can see it visually on a digital screen and prioritize your time of where you need to go. So over the last 10 years now, we've developed one of the largest crop libraries to be able to do that by species. We do this by, like I said, acquiring the data through drones, and it's all full service model to you guys. We have the pilots, we have the operations team. You provide us your boundary and your field data, and we do the rest for you. You're using that information to make valuable decisions, whether you're on the farm, you're at church, or you're on vacation with your family. You can still see your farm wherever you go. Then we take all of that data from the drone, we analyze it through different methods of AI. We have two that are currently in our system right now, the AI that identifies those images, and then the AI that's called Ag Assistant, that pretty much is ChatGPT for an agronomist. It analyzes an entire season, precipitation, soil temperature, things that are happening out in the environment, everything that's identified within those images, and then spits out a report so that you can have a full field report card for every field that we fly, and then that all allows you to take action on your field. And like I said, full service model. All of this is on our website, Taranis.com. We don't have a booth here today. I'm just here to speak with you. But there is a contact us page that will direct you to the customer support team on Taranis.com, and then we'll be able to inform you even more about what we can provide. But basically, this is what one of the drones that we fly, that we cover the entire Midwest, all the way from Nebraska to the Delmarva area down to Texas and up to Minnesota and Wisconsin as well. And we also offer satellite imagery that goes in complementary service along with our drone missions. Thank you.
Thank you. And just a reminder, if you have any questions, just shout them out, please. And without further ado, we'll kind of get into a roundtable conversation. I've come up with a bunch of questions. But before we begin, I just kind of want to ground us in the present state of AI. And I mean, for many, and for myself included, it seems like AI has kind of exploded into the ag space, but it hasn't really. I mean, it's been under development in adjacent and other sectors for a really long time. And basically the reason why it's emerging into ag so quickly right now, as I see it, is that we've sort of reached a point in development of AI where we can understand the physical space around us. And now, instead of just using abstract theory, we can suddenly release it into the wild, into the real world. So maybe to begin with, Ben, could you just walk us through the history of AI, how it's developed, and also explain the term AI is broad, artificial intelligence, but underneath that sort of term, there's a lot of different ways that AI interacts with the world around it. So could you just walk us through that, please?
Sure, I could do that. When we talk about the age of AI, it's sometimes difficult to hear that AI was actually conceived in the 1960s, and the mathematics behind AI was formalized and written in the 1980s. So it's not necessarily a new technology, it's just that we've been unable to make the mathematics useful. So as an engineer, a lot of my job is trying to figure out how do we take a lot of complex technology and how do we actually make it useful? Because something that's useful and clever on my desk sometimes is completely useless in the field. Now, in AI, if we want to just very quickly define AI, if you take mathematics and you take programming and you bring those two together in a way that it mimics a human's ability to learn, that is AI. So that's artificial intelligence. That's why we call it artificially intelligent. The way typically that it works is you have training. So we'll take this combination of math and this programming combination, and we'll expose it to a huge amount of data. And we'll just say it could be data that's either textual, so we could go through textbooks, we go through databases, and it learns on top of that information. And then we switch over to inference, which is where we'll interact with an AI. And you'll either ask questions or you'll put it in a system and it'll give you an output back. Now, broadly speaking, that definition applies to all types of AI, but how that AI interacts with the natural world is kind of where the distinguishing factor comes. So if you have AI that's text-based, it's NLP AI, natural language processing. If you have AI that's vision-based, that's usually camera-based processing. But broadly speaking, they generally follow about the same pattern and the same interaction.
Dan, could you explain the different types of AI and really focus on language modeling?
So there was a pivot in 2017. That's when Google launched this paper that introduced the transformer. And so just bridging from kind of the history of the 60s to what is really new now is it went from where AI was really just like a calculator. You put something in and you can do some analysis and give you insight, to now there's this transformer, which really makes it more knowledge as a service. And so we call that prior version before 17 perception AI. And that's this unstructured data that comes from sensors, comes from hardware. And you can run analysis over that. And a lot of the software companies in ag that existed were really geared up to visualize that unstructured data and analyze that unstructured data. But now we've pivoted to generative AI, where you take a file and you put it in and it converts it to numbers. And basically what this transformer does is it's a predict the next thing machine. And surprisingly, it replicates knowledge really well. And it's kind of a black box, but that's really how it works. And it can do that for text, it can do that for a pixel to generate an image or a movie. And we're just making that better and better, where it's better and better at predicting, given one pixel, what the next pixel should be, given constraints in a prompt. And so that's generative AI. What's next is agentic AI. And that's where you pivot from you, the user, put in a prompt and it kind of spits something out. Agentic AI is you tell it to do a task and it will go on your computer and go into other programs to do the task for you. And then progressively that's going to move into where you could tell it to do something and it'll be able to overtake robots to go do something for you in a physical environment, more humanoid robots. And that's where we're marching towards. And I think what's really crazy is how fast we're moving towards that, where it's been around for a long time. internet took 30 years, cloud took like 15, to the space of moving from infrastructure to real world applications and Gen AI has been like 5 years. And so you're seeing just this really rapid movement of innovation and it's really compressed timeline of the value coming from these solutions. So it's pretty exciting.
Katie, could you walk us through how you train an AI?
Well, it depends. So there's multiple different ways that you can train, but typically when you're training an AI, it's repetitive, time after time, going through the data. Sometimes it's actually, like for us, it was human agronomists going over image after image after image saying, yes, this is tar spot, yes, this is tar spot, no, that's not, that is bird poop, and then going back to tar spot. Yep. Her question was, how are we avoiding hallucinations with AI? It's difficult, but I think we're a lot further ahead than where we were when we started, obviously. But I think the only way to avoid that is by continuous training, not resting with being okay with where we are right now is by continuing to feed it back. So for example, with Taranis, when we're identifying actual things in the imagery, if something's wrong and it's reported from the field back from our agronomists or our growers, we feed everything back into the system. And then in our off season, we take all of our millions of images that we captured and we're feeding it 3 times through the system for that following year to make sure that everything that was currently identified is actually what it truly is out there.
What's a hallucination? Could you just clarify that?
Just comment on hallucination. So because these things are predict the next number machines, sometimes they predict something wrong. And it comes out and it makes no sense, right? And to your point, like there's been a lot of progress in a really short period of time. Is that still on? And really the three main training methods that are making a huge difference are, one, fine-tuning. So that's really been the realm of the big tech players where they can do this basically you train it to understand and you give it a big corpus of data and they use synthetic data to run it through what that document means or what that image means and it starts to understand patterns. And then you have this training method called RAG. And what that does is the process you guys went through where you're fine-tuning with experts saying lots and lots of iterations of like, no, it's this, no, it's this, no, it's this. And then the final one is called reinforcement learning, and that's DeepSeek, which was all over the news, the method that they really use to get high performance. And that's where you, in their particular method, they actually used an LLM to do the reinforcement learning, but you reward it for getting it right, and then it just keeps seeking that reward. You can do it with people too, but those 3 methods are really why we're getting this rapid climb in capability that's happening so quickly.
There was a question all the way in the back.
A question in the back.
One of the best ways to think about the capabilities of modern AI today is to think of a library. So in a library, you have a very big collection of information that's structured and stored in a very specific way. And you have a librarian that serves as the interface between the rest of the world and that information. So if you go to a librarian and say, I want to learn about physics, a librarian can point you to a shelf with a couple of books, and it's up to you to go into those books and find that. With AI today, as we get better at processing information and as we get better at storing information, our capability to meet the specific answer that we need in order to meet the needs of a specific question becomes even better and better and better and better. Now, our trust and verify process in that AI is kind of what they've alluded to here with this reinforcement mechanism. It's when you loop it back. So AI is a numbers thing. It looks at numbers, it looks at probability, but numbers don't capture 120% of all the variability. So the way you loop that back is you keep the people in the seat. So in the case of us at AGCO looking at in machinery, my role with AI is not to replace the farmer, it's to keep the farmer in the seat, keep the farmer in control. But can I give higher quality information to the farmer? Can I give a better decision-making ability to the farmer? And that's kind of where AI, a lot of its use cases with people and is headed, and how we can make sure that trust and verify stays in place.
Can I add to that? I think one interesting distinction there are we view accuracy and trust as two different things. So I'll give you a human example. Like if I ask you a question, you don't have to know the answer to every question for me to trust you. But you're going to lose trust in me if you bullshit me and give you an answer that's not. I'm sorry if there's children. If you give me an answer that's incorrect, I'm not going to trust you anymore. But if you just tell me, hey, I don't know, right? That builds trust. And I think we have to think of the tools the same way. Is yeah, we can make them more accurate by doing what we call benchmarking. We give them tests that experts have built with verifiable right answers, and then we compare their answers to those verifiable right answers, and we can see how accurate they are. Trust is where we're training it on features like things like return sources so I can see what sources you used, or show your thinking of how you got to this answer, or give me a color-coded thing about your confidence in this answer. And so I just distinguish between accuracy and trust and how we can build those features into these models.
I personally, I think we also hold AI to a standard of perfection. But if you compare it to a human, I mean, if I was to ask you 90% of the questions that an AI could get in 2 seconds, you probably wouldn't know a lot of them. So, I mean, I think our standard for AI is significantly higher than humans. And I also wanted to note that a lot of AIs work within a closed system. So, for example, Texas A&M just introduced a librarian for peer-researched papers on agriculture. So the information that you're getting from that is peer-researched, and it is accurate. But if you compare it to, say, an AI that's pulling information from anywhere in the internet, you don't know how accurate that information is because you don't know who it was that created it. So I think it depends on where the AI is coming from, the information that's pulling, and what it applies to. Oh, couple questions up in the front.
Back 50 years ago, my dad used to call it garbage in, garbage out, when talking about some of the results we got from the computer for the milk testing, et cetera. Are we going to have this problem with AI at some level?
Yes, that's a very good way to explain it. If you think of that library methodology, if you populate that entire library with a bunch of rubbish information, doesn't matter how good the librarian is, it's going to return back rubbish information. So as we improve our AI systems, we're both focusing on how do we make the librarian accurate, better, quicker, but also how do we make sure that the information going into that library is good? Where's it coming from? Who's authoring it? Who's creating it?
And to that point, I don't think we're saying that it's smarter than the experts. It's just smarter than any one given expert because it has so much more it can access.
Correct, yes. If we judge people's intelligence by how much you can memorize, then it's a very poor measure of judgment. There's so many people we meet on an everyday basis. They don't necessarily have a PhD, but I wouldn't dare argue with them about anything. And a lot of that is in farming. I wouldn't dare argue with a farmer as an engineer. I may know a lot about engineering and a lot about tractors, but a farmer knows way more about farming than me. Similar systems in AI too, similar things.
Yeah, and if you think about it, this is probably one of the questions is it going to take my job? Is it going to do what I'm already doing? Well, it's not going to take your job, but your neighbor that's using AI will take your job. You know, so to be on the cutting edge and the front end of all of this, we get that question, excuse me, all the time. Is it you're replacing me as an agronomist? No, we're taking what you're doing, whether it's farming or using machinery or reading data or whatever your job might be, and doing it better, doing it faster, so that you can prioritize where you need to go and why you're going there, rather than spinning your wheels or heading north instead of south or whatever it might be. Now you can focus and create more ROI for your customers or for your company or even your farm.
Any other questions?
Yep. So, and they do, there's a tech stack, right? And energy's at the bottom, and then processors, which is NVIDIA, and there are other players now besides NVIDIA, but NVIDIA is the dominant player. Hopefully you guys all had stock. I didn't buy enough. But then after NVIDIA, you need cloud to run a lot of this stuff. So you have cloud players like Microsoft, Amazon, Google, and then there's your frontier model makers, and that's where you see OpenAI is the one everybody knows because of ChatGPT. But less well known is Anthropic, which makes a really sophisticated model called Claude. And they do a lot for government because they're super secure and they're pretty high performance. But a lot of players are getting in, like X, Twitter, they have Grok, XAI. Meta, Facebook has Llama family of models. Google has Gemini. And then there's smaller players hopping in. And what we anticipate is it's going to be a many models future. That there'll be these frontier models, and they're going to all compete to have high performance. The performance of GPT-4o, the cost of performance improved 1,000-fold in 18 months. That's crazy, right? And so you're going to be able to access really powerful capabilities really rapidly here. But what we think will happen is each domain will start to develop models specific to the domain, and that's what, like, Bear's developed a small language model for agriculture. And we think there'll be more of that. They'll make one for oil and gas. They'll make one for finance, or many models to get to that. Like, what does it really have to know to do agronomy well, and really start to fine tune for that type of information.
So I'd just like to take that question of training a little bit further. We've talked about librarians gathering information, but how do you train a machine in the real world to be able to avoid, say, an object, or be able to differentiate, a rock from a plastic bag? How do you do that? I mean, if you're taking the same philosophy of feeding it, thousands and thousands and thousands, millions maybe, of little pieces of information, you can't really do that in the real world. It would just take up way too much time. So could you explain what digital twinning is and how we can use that to teach things in the real world?
Sure, I can do that. I'll answer the first part there. The way that we make the systems better, for example, like avoiding obstacles. We had the example up there about AGCO's Outrun autonomous tractor. The way we avoid running that tractor into stuff is we add sensing to it. And that sensing is similar to what we as humans do. So we have depth perception. So when we look, our eyes look, I can see color, I can see structure, but I can also see distance. Now, in sensors, we can do the same thing. So I can put a camera there. Camera can see structure, and it can see color. And then I can use sensing technologies such as LiDAR to see distance as well. So I know there's a person over there. Let's not drive there. And over there is 10 meters or 6 feet. So we can add that capability there. Now, as we enhance that, we enhance it by adding more sensing. So then we'll start putting cameras more around it. If you think of a Tesla car today. A Tesla car has 30, 40, 50 cameras throughout the whole car. Together, they work as one. Each camera is focused on a very special part of what it's working on. Second part of the question? Digital twinning. Digital twinning is a technique that's actually existed outside of AI. It was very common in the military and is starting to permeate into the rest of the industry. So we think about AGCO today. We build tractors, we build combines, we build big machinery. When we go and create that thing as a prototype, we have to be very careful about how we do it because there's a lot of safety implication there. It's a big machine. A Fendt 1167 tractor is 6-7 feet tall up to its roof. A Fendt Rogator is even bigger. So by the time software and electronics and mechanics and welding and all of it meets up to create that machine, we've got to be very, very, very sure that it's secure and safe. And the way that we do that is through digital twinning. So digital twinning is where we say, let's go and create a virtual copy of that machine or its environment in software, and let's simulate our testing ahead of time. So it's not perfect. We can't copy 100% of the real world, but perhaps I can copy 80% of the real world. Because then I can figure out 80% of my problems in a laboratory somewhere without first needing to go into the field to do it. So by the time the product makes it out in front of a farmer, that thing is most of the way there, at least at prototype stage. So digital twinning is a very, very important process that we go through to make sure our products meet the needs of farmers, but it does so in a very quick and safe way. I don't need to learn 3,000 times with a tractor. I only need to learn once.
Dan, could you explain how this applies to, researching crop science and coming up, with the most optimal type of crop?
Yeah, so we use environments for R&D and Bear, and we've used digital twin for a long time in kind of our R&D development of building hybrids and products. So running simulations of digital twins of new proteins, new active ingredients, new hybrids, to be able to get better prediction, because ultimately it's a numbers game. And if I can run 1 million digital simulations before I do the physical one, then my odds of getting a blockbuster hybrid are a lot higher. And so we do a lot of the same things, right? Is like, wait and do the physical piece when you kind of know you have a good bet of you're going to get a good product in the end game, because it is ultimately just the numbers.
And AI is constantly learning. Katie, could you explain, how these models continue to advance and become better through inputs that we give it in the real world?
Yeah, so as with anything, even if you are a human in school, the more you put in, the more you're going to get out. But you do run the risk of, whoever said it, of how much data becomes bad data. But with tailoring these AI models and being able to put in certain parameters and put in exactly, what are the outcomes that you want, that's where we can take all of these inputs that we have, because I know you guys have binders and just storage of data that we might not be using fully or well, and we can take that and really, really extract the information that we need to get to where we want to go.
Do you use historical data as well? And what other types of information do you pull in and combine with that telematic data that's coming off the machines?
Yeah, so everything within Taranis is stored for how it's up in the cloud. It's there to access as long as you need it. The next iteration of our product is going to be looking at historical data. So this past year was looking at specifically what happened during this growing season. What was the precipitation? What was the soil temperature? What was the NDVI? What insights did we receive back for stand count and weeds identified by species and diseases and nutrient deficiencies that can help us tailor what are we going to do next year or in 2 years when we do that crop rotation. Now that we have multiple years of data, we can take a couple of years back and say, okay, a couple of years back, this is what we found. Now that we're in this crop rotation, we're going back to corn. After soybeans, this is what you saw a couple of years ago. This is what we recommend to do. So that's our next phase through our product.
Just out of curiosity, when do you think something like that, because it seems like projecting forward would be really, really, really helpful. How far out are we from that?
Projecting forward is dangerous. Everybody asks you, do you have a yield calculator? Do you have a yield projection model? And it's hard because there are thousands of factors that every year are unpredictable going into growing a good corn crop. There are so many things that we cannot account for that even if we predicted X, Y and Z are going to happen that we weren't ready for. So I think we're very close to being able to predict forward, but you have to take that with a grain of salt. You have to take it as a boundary of where we could lie, and then anything can happen within that. It's very dangerous coming from a tech company.
I would add that one of the things that I think is really exciting is, so these models are really good at information retrieval, right? We talked about this. There's really, versus a human, there's no limit to the amount of information they can gloss over rapidly and give you a return. They're also, because of natural language processing, really good at synthesis. So they can look over a big body of text and tell you the key themes or the key insights. So like your notes, they could go back and look at all your notes and say, well, these are the themes and things that you should think about. Before we jump to the future, though, I think what's really exciting is then now with companies like Taranis, you're looking at where you can integrate language models that are high performance with real-time insights from, say, drone images for applied agronomy. So before you get to predicting the future, you can just do real-time stuff where these models, you can teach them to do what's called context hunting. And so they go and they look for what information do I need to give you a really good action plan. And maybe one of those things is a drone image from Taranis saying you got tar spot at V4 or something, right? And with leaf recognition, like the capabilities they have, we'll be able to do that. You'll be able to plug that into a model, and it'll say, hey, your drone image saw this, and we need to think about taking this type of action. Here's 3 products from Bayer Crop Science that address tar spot, and you want to apply them this way. So I think what's really exciting is where in ag we've had this long problem of being able to get to action. These models will be able to close the loop and get us to action.
Question up front.
With the 800-pound elephant now being an 8,000-pound elephant, how the hell are we going to pay for this? I assume on the left we're going to pay for it by so much an acre. We're going to pay for it in the middle by increasing the product price, and the bend increasing the equipment price, or are we going to pay an acre through your process too?
We're busy engaging with farmers to figure that out there. We had a big farmer day 2 weeks back at one of our big sites. One of the things AGCO started doing is we bring farmers in at the very start of our process now. So what you were seeing up there on the screen is a prototype. Before that prototype was built, we had to sit down with farmers and we said, look, here's our idea. Does this sound stupid or not? And one of the key takeaways that we got from that is farmers want a choice. They don't want to get told the only pricing mechanism that you have is to do this by acre. They want to have a choice between, okay, you can either do it by acre, or maybe you can do it per year, or maybe you can do it once off. Give them a choice. So as at AGCO, that's how we're approaching this. We're trying to figure out how can we give the most choice to farmers for each situation to allow each farmer and each operation size to make that decision as it's relevant to them.
With your equipment, we've got a piece of equipment left physically. The other two, we have nothing once the product is delivered to us. The seed is going to produce a crop. The flyover is going to tell us we had a problem last week. So somewhere we got to pay for it again probably.
All right, I hand really quick. So the Bayer solution is not for growers yet. Mostly our focus is to empower our salespeople to be more efficient and effective at positioning products so you get more out of our products. So we're enabling them with better tools to position more effectively. And look, that's the roadmap is in the U.S., it's going to get harder to position ag products, right? We all have a political wall we're up against. Using crop protection products is going to get really difficult. Using systems of things like short corn, where you're integrating both the seed with new fertility and CP regimes, it's more difficult, and you're going to need tools like this to get the most out of them. So our view is if we make it so that these tools provide a better experience with those products, you'll like the products and buy more of them. We're not looking at a direct farmer monetization model today.
Yeah, so everything has a cost, and it is a $1 per acre cost. But our turnaround time is 24 hours. So if we're flying a field, if I have a pilot flying a field today, it's being uploaded, processed, and you'll have a notification on your phone that you'll have information tomorrow. That's how fast that all these models can work. Typically, in agriculture, we're looking for problems, right? We're looking for where's my poor stand count? Where do I have high weed pressure? Where do I have diseases? What can I go do? What do I have to pay for again? But Taranis is also a reassurance tool. It's confirming what you did was right. How many decisions do you guys make on your farm that we're unsure of at the time of the decision making, how much of an impact it's going to have on our farm? So now when we fly over those fields and we're seeing clean acres, or we're seeing really good stand count, or we're seeing early catching of diseases, and we can actually do something about it to save that crop, that becomes a whole different discussion that you have with your agronomist. So it becomes a reassurance tool of not just confirming that things are going wrong out there and having to call your agronomist and get more product and get this and get that. Well, now, hey, Mr. Grower, you made a really good decision this last fall. We had a tailored, plan for your fields, and it's actually going well. It's going right. So congratulations. I mean, my dad has very rarely heard a congratulations on the farm because everybody's always looking for something wrong. So I think that can also be taken as a more positive outcome to all of this faster processing, faster data. But I mean, everything has a price, right?
I've got a lovely story I can add in here from an interaction I had with a colleague of mine. So whenever I come up with some new idea and some new thing that I want to think of and have a software team work on, the first person I call is not an engineering team. It's a guy who's been working for AGCO for 37 some years in southern Minnesota. He's himself a farmer, good, hard man, and lovely to talk to him. He has all the wisdom in the world. And after I'd explained AI to him, which took a while, and he understood it, the way that he explained it back to me, the story that he told me, is he said that when he grew up, Grandpa used to sit on the porch. And when Dad went out in the morning, Grandpa would tell Dad, "You're doing it wrong." And when Dad came back at 5 o'clock, Grandpa would ask Dad, "Did you do it wrong?" And Dad would say, "Yes, I did it wrong." And he understood AI to be that capability in the cab of a machine. So we can do that in the machine. And it's not there to say you're doing it wrong. It's more there to say you're doing it this way, but have you thought of doing it this way? You still have the choice to do it that way. If you want to go do it the other way, that's up to you. If you want to do it the better way or try a different way, you can do that too. If you want to make use of all the information that comes in through all the other different places, AI can help you do that. It can help you say, well, based on your machine data and based on your crop data and based on this and these other data sources, here's a different way you could do that. Or here's perhaps a better way you could do that. Or maybe you should drop your RPM in your machine a bit. You're saved quite a bit on diesel, stuff like that. And that, I thought that was a lovely way to put AI and how we can use it in agriculture.
We had another question in the back, I believe. So I believe the question is around the validity of data and how we make sure that the information we're putting into AI is accurate and not biased based on brands, correct? Would one of you want to answer that?
From my perspective, we have these wonderful land grant schools that do research, right? And like both in field research and kind of in lab research on ag products. And you have this interplay, at least, you know, of I think about seed and CP, where companies produce research trials, academics produce research trials, and that is a way of getting kind of a review, right? Can you independently validate each of them? And often they don't agree, and then you say, well, something's messed up there, and sometimes they do. And that's the process of science, right? Is when you can get independent peer review, you know you got good science. If you can repeat the experiment, you get the same results. And so this garbage in, garbage out, I think you want to prioritize using those sources and putting them in there. I would say, though, one of the things we see is this concept of bias in models. And in these frontier models, they're doing a lot of scraping, is what they call. So they go in and they kind of pillage websites and they take stuff out. And that's under legal review. There's gonna be some conflicts there. But one of the things we see in some of these models is their lack of understanding of production agriculture and high bias towards organic agriculture. And I mean, I think this is something that we have a responsibility as ag firms to really kind of root out is that, you know, like we need to make models that understand real world agriculture and are built on land grant and really good peer review science of studies of applied agronomy and get models that are built from that foundation. So it's a great opportunity in front of us to really provide something different than these technology companies are, and they're missing what, you know, the way real ag works.
One of the ways at AGCO that we make sure we are grounded in the truth of what a farmer actually sees is two ways. I started that badly. We have two ways. One, we employ farmers So there are people in our engineering teams and our validation teams who themselves are farmers. That's why our sites are in the Midwest. The second way we do it is we have an agronomy division that actually farms themselves. So AGCO owns its own farms, that we have people who are employed who go and farm them, and then that real field data comes back into the company again. So we'll have a claim and we'll say, our engineers say this machine will do this. And our farmer, who is employed by AGCO at that farm, will then take that machine, go and test it for a season, come back, and he'll either be able to say yes, or he'll be able to say no. I had a lovely response from one of our internal, from the same guy I was referencing earlier when I explained a feature to him. And the way that he explained it back to me, and I took that back to management, was that's about as useful as a brick in a pond for floating. So we make sure we're still talking to the farmer throughout the whole process of developing this stuff, and not just relying on theoretical information. There's a lot of great academic information and research, but ultimately still staying down, grounded on the farm with the farmer is the best way we've found to do it.
Yeah, and we're very similar. It comes down to the education that we can push out to the world, about AI and about how to use it and how to interpret it. So the team that I lead at Taranis is a customer success team that's not a call center. We're not answering phones that's saying, oh, this is Taranis, how can I help you? Oh, you have a problem, let me submit a ticket. Every member is dedicated to a specific account and to work with those growers and retailer agronomists directly, to where we're taking the real life insights, we're working with them day in and day out, we're getting feedback from them, and then we're sending it back to the product team, to the marketing team, whatever it might be, to make sure that we are continuing to provide the best service and the best product out there. So that's, I think, is a very key factor of having farmer employed, farmer owned, farmer touch points, is to making sure that everything's valid going forward.
And I want to put in a plug for extension services. And I mean, farmers might not necessarily see the research that goes on at universities, but that's why it's so imperative, is so that it can be peer researched and that that you're getting non-biased information that's rooted in science. Any other questions before we move on? We have about 5 minutes left. Yeah.
So I know you haven't gotten into the historical data part, but what are the ROIs you're seeing for these farmers with the technology that Taranis brings to the table?
So it's going to be different for every farm, right? Because what's important to you is not going to be important to you and not going to be important to you. But the bottom line, the importance is making money, right? So, but you also have to think about the ROIs of scalability, of being efficient on your farm, of bringing expertise to your farm, or even on the business side of it, differentiating between your employees of being able to use the AI and not being able to use the AI. And that, as harsh as that sounds, that comes back to it's not replacing your job, but if your neighbor's using it, then they might replace your job. But with Taranis, being able to analyze year after year, we can go back, but we're not at the point of using those predictive models for the historical to bring forward to predicting the future of anything. I don't know. Do you guys have anything to add on ROI?
There happened to be a massive study done that was released today on the U.S. labor productivity impact of Gen AI, and agnostic by industry, and they just looked at use by industry, use by individuals. 30% of individuals are using Gen AI. Almost all of those that use it regularly, and they're using it across a pretty large cross-section of tasks, from writing to critical thinking to kind of systems analysis to coding, and the average productivity increase was 200%. And very rarely, though, does Gen AI, when you ask it a prompt, give you a 100% complete answer. And so this is the interesting thing for those of us that use these tools every day is we get that. We get that we're going to ask it a question and it's going to come back and give us 50%. But that's 50% further than I would have been if I had to do it on my own. And so there's value in that. It might not be all the way to 100%, but there's value in that. And I think it's just unbelievable to me that 30% of the population is seeing 200 to 400% productivity improvement. 70% of the population hasn't even looked at one of these tools. And these tools are getting so much better so fast. It really is. It's amazing that both those things can exist. And the industry with the lowest use was agriculture.
And I would argue that it's an industry that needs it the most because so many farmers are retiring and they're taking all of that information, all of that knowledge with them. So what's the younger generation going to do? Would you like to answer that same question on quantifying ROI? How do you do that with AI?
The way to quantify ROI, the simplest way and the best way is actually go and test and use it. So at AGCO, we've made huge efforts in the last couple of years to move our engineers closer to the field, to the point where we have a group of farmers that are under NDA with us that get brought in from day one with our engineering products. And then we say, right, here's our ideas. This is what the engineers thought. What do you as a farmer think? And then we work and iterate through that. 6 months later, once we have a prototype that's done, that prototype goes back to the same farmer then. Says, okay, we took your inputs, we created something, you go and test it. And if that farmer comes back and says, oh, you know what, this really did work. I did get a 20% yield improvement or something on my farm. Then we can expand that and go further. But there's no magic way to avoid doing that. The best way to do it is just go and do it. Just build a relationship with farmers. You kind of speak earlier to the trust part, build that trust. If we're going to create solutions for farmers, it's got to be created by farmers. And you do that by just bringing it in early on.
We only have a few more minutes left, so I'd just like to go down the line and just ask, does AI have a limit? What's the future of AI? Where do you see this going within the ag sector?
Definitely. AI does have very big limitations. Its use today is best described as kind of niche. It's a very surgical scalpel for very specific things that you can do, but it's not going to cover all the use cases. The way to make sure that AI is useful and effective is we've got to be judicious about our guardrails. That could be both in terms of data, so speaking to the credibility of the data, where are we getting our information from? How are we getting that information? Is it trustworthy? Once we've identified bad data, can we go in and remove that bad data too? But it's also to ensure that we need to remain grounded in who it is that's going to ultimately use this. If AI is a tool, we need to go and test this with the people that are going to use these tools. So the limitations we impose need to come through that testing. We need to go and see, okay, the farmers tested this, they didn't like it, let's take it out the machine. So AI, I think, is going, where it's going next is it's going to come closer down to the user. So if we think about what the smartphone did to mobile communication, we had telephones for so long, and then with the advent of the smartphone, we have walking around with us today more compute capacity than the entire space program that put people on the moon. That's incredible. There's so many different ways we can use it, and we've come to use it that way. The way we communicate has changed, the way we access information, the speed. I think the same thing is going to happen with AI. It's going to come way closer to us. It's going to be a lot easier to use, and it's just going to make a lot more sense there. It's not going to be this fanciful thing that the engineers created in the back room. It's going to be something that I can use it every day. I can have my dad use it. I can give it to my grandpa, and he can use it and understand it. So that's where I see AI going forward, is making it more accessible and more usable to people.
Dan, taking that a little further, what applications maybe aren't using it right now that in the future you could see it being applied to?
Oh, goodness. I started with, you got to start with a problem. I think there's a lot of problems that we could solve with it in agriculture. Like you talked about extension. Extension's wonderful. It's been wonderful for the world. But the fact is it's constrained because it's human, and it's hard to get to all the farmers because farmers are spread out by the nature of farming, right? And so here's an opportunity to make it digitally scale. I think about, like, I know it's, India, there's 20 million farmers in India. Our people in Bear can reach 1.5 million of them. The channel can reach 3.5. They all have phones. Here we can make a tool that can give them products to consider and a reputable place to buy so that they don't get gouged by kind of piracy in the retail channel, and make sure that they're using products effectively. So that's pretty game-changing when you think about it, when you can deliver a tool that can do that pretty easily. And I think that some of the future is, I totally agree with you that what's going to come really fast is putting these tools in your hands. And then you'll get the opportunity to figure out how they work for problems you have. I would start today, if you haven't used ChatGPT as a travel agent, Highly recommended. It's wonderful. Get started with that, right? And then go from there.
Katie, final thought? Take us out on the future.
Such a big question. You guys hit it so well. I don't even know what else to say. No, I think it's here, and we have to embrace it, right? It's the same with, took my example with the phone of having just a walking internet with you, but I mean, we had Google, now we have the cloud, we have cell phones with everything that are capable of doing from your phone. It's a mini computer in your pocket. I think it's here, and that we honestly have no choice but to embrace it and to use it for what we need it to be doing on each individual farm, whether it's, for livestock or for cropping or for even as an ag retailer, making sure you're just being the right experience for those growers, and that you're getting the experience that you should deserve, because everybody has a product and a price. But why do you do certain business with certain companies is because of the experience that you get, and AI is just going to take that experience to another level.
Well, thank you all. This has been a really fascinating panel. I've enjoyed it. Thank you all for your attendance. I'm going to write a little article on this, and I'll post the recording with that article on farmprogress.com. So if you are interested in the recording, you'll be able to access that in a few weeks. Meanwhile, if you want to take our survey, tell us how we did, you can be entered to win a gift card. So I just really appreciate all of you coming here today, and I hope you have a good rest of the show.